Today, I'm going to be talking about adversarial examples and specifically what it takes to trick an NLP model or a machine learning model in general, and what sort of issues arise with that, and maybe how we could use that for our own benefit. So just as sort of a refresher on explainability in machine learning, when we have really big machine learning models like deep neural networks and big convolutional neural networks, something that happens is that we get this effect that's kind of known as like a black box, which means we put in all our data and then our machine learning model does something to it, and then we get out these results, and these results can be pretty good. Like state-of-the-art machine learning models have achieved like some pretty impressive accuracies on in a lot of domains. But essentially what this black box represents is the idea that we don't know what the machine learning model is doing. Like the way it works, the way it makes its decisions, and the way it sort of creates its results are almost completely unknown to us. Usually the bigger and more complex the model, the less ability we have to analyze the mechanisms that influence the decisions of the results. So essentially we have this sort of powerful tool, but we don't understand why it works. So put in the chat, what might be some drawbacks or negative consequences of this phenomenon? What do we think? We could think in terms of like real world application. Could be helpful too. Right, awesome. So great answer. So troubleshooting would be hard, right? When things don't work, it's hard to analyze what's going on. It's hard to understand why it's making a mistake. If we think about a traditional sort of computer science approach to solving problems, we create this somewhat deterministic program. Maybe we can have random elements, but in normal computer science, when we solve a problem, we make all the code ourselves, and we understand the logic of how we go from our data or our input state to our results. And if we have something that doesn't make sense, we can sort of analyze our code and find out where the thing that isn't working is and try to fix it. But because this machine learning model these big machine learning models are so unexplainable, like we don't know how they get the results, it's really hard to analyze basically how they're making the choices they do, which makes it hard to both sort of troubleshoot what might be going wrong. Often the only sort of answer we have is to sort of try to change the model and train it again or augment our data. But it also allows the potential for essentially adversarial examples. And what adversarial examples are inputs to machine learning models that an attacker has intentionally designed to cause the model to make a mistake. And so this can happen in normal sort of in non-machine learning systems. Attackers design things all the time to sort of create bugs and vulnerabilities in that kind of code. But we can identify and fix those issues when they arise, because that code is so much more transparent and we understand what's going on. But with our machine learning models, adversarial examples can be created that trick it, and we have no idea why it tricks it. So for example, imagine we have a picture of a panda, which we have a model that tries to classify something as an animal, and it has a bunch of different animal classes as potential outputs. And so originally it thinks our panda here is a panda with 57.7% confidence. However, we can sort of apply this sort of filter, or this random, it's not random. Usually these sort of attacks are created heuristically by analyzing the model and exploiting its weak points, but we can create this adversarial example. So the combined new image would be an adversarial example because our model misclassifies it like so wrong. Like it thinks it's a given and it's 99.3% confident, which is crazy because originally it's only 57.7% it's a panda, but now it's 99.3% confident that it's something else. So there's massive potential to exploit these vulnerabilities in our model and basically trick them. So one sort of important distinction here is that an adversarial example isn't just like gibberish that we give in our model. We don't just want to like give it in like an invalid image and then it gives us a bad output and we're like, oh, we broke it. Specifically, adversarial examples are instances where we want the model to have a desired behavior on that input. Like if we were to give it this picture over here on the right of the panda, it should output a panda because that is a picture of a panda. That's what the image contains. But instead, our adversarial example tricks the victim model essentially into making the wrong classification. So this is sort of what an application in computer vision looks like, but we can actually apply this to other fields as well. And some work that I did recently was applying this to NLP. So we can sort of remember back to our Yelp classification notebook that we did last week. And we had a review and we had to classify it as either a positive review or a negative review. So in this case, take this top example here, very high quality food, friendly service, and a clean environment. So that's a positive review, and sort of we can think of this is our classification by the model, either smiley face for positive review and unhappy face for negative review. So we can actually sort of make this adversarial attack and change out some of these words in order to basically trick the model into thinking this is a negative review. And so what's crucial here is that we don't change the actual meaning of the input. So very high expectations for the food, great service, and a clean environment. That is still, like, as human laborers, we still say, okay, that's a positive review. So the truth, like basically similar to what we saw with the panda, the desired classification doesn't change. What changes is our model's interpretation, and therefore that's how we're able to trick our model into making the wrong choice. And it turns out there's actually doing adversarial examples in NLP is actually a little more challenging and complex than images because of basically the nature of our input. Because remember, when we have text as input to a machine learning model, we have to do this pre-processing where we create word vectors and use those word vectors to run through the model. And also, sort of, these words are discrete, like they're independent things. We can't change like a part of a word maybe to trick the model a little bit, because then it wouldn't be a valid input anymore. So we need to maintain like the grammar of the input, the original meaning, all the while basically tricking our model. So why might this be important in the bigger picture? In safety critical systems, like unexplainable errors and basically attacks that produce undesirable behavior have very high consequences. And it's dangerous to have that vulnerability lying in your system when you don't even know how to fix it, essentially. So put in the chat, how might we able to make our models better or more resistant to these adversarial attacks? Anybody have any ideas of how we might be able to do that? Awesome, great. I see a lot of great answers. So I see some answers that focus on sort of understanding what the model is actually doing. So increasing the how we can explain what our model is doing. And okay, train it on adversarial attacks. That's a good idea. So if we show it where it's making mistakes, maybe it can learn to not make those mistakes anymore. Right. So there's a few approaches that are generally used to sort of try to increase these or improve improve performance on adversarial attacks, and that's to, like some of you guys said, to improve the model architecture, to increase its abilities and make it sort of better at capturing the desired patterns and be more resistant to adversarial patterns. We can also basically create better representations of our data. In NLP, that means better word embeddings, because essentially we can think of NLP in our sentiment classification example. The issue arises from the model not having a deep enough understanding of natural language, and specifically the words in natural language. So having better representations of those words will lead to more accurate classifications of the text. And there's also, like someone mentioned, adversarial training. So using those training examples or those adversarial attacks themselves as training data to basically show the model, okay, this should not be a given, this should be a panda, or this should be a positive review instead of a negative review. So how do we actually go about creating these adversarial examples in NLP? There's a variety of ways, but one way that I was working on was using text generation models. And the reason we decided to do this was because text generation models tend to have some of the best sort of capabilities among modern NLP models at creating syntactically valid text. And we thought that being able to basically create this cohesive text as adversarial attacks would create better adversarial examples. So if we remember back to our text synth activity, where we basically put in our starter sentence and pressed like complete sentence, and it would fill in like a paragraph for us, that was a text generation model. It uses the words that come before to basically predict the next word, and then uses all the words again, including the predicted word, to predict the next word, and it'll just keep going as long as you want it to. And we actually had to use another technique called infilling in order to basically allow us to make certain adversarial attacks like insertions and merges. But that is outside of the scope for right now. And we were able to either maintain or improve upon the attack success rate of current sort of methods of doing adversarial attacks. So Glare is our models, and these were different configurations that we used. And Claire, Text Fuller, and Bird Attack are some of the existing models used for creating adversarial examples in NLP. And we also created significantly better, not significantly better, but either better or slightly better or the same similarity between the original sentence and our adversarial sentence. So our text generation model was better at preserving the meaning of the examples when we turn them into adversarial examples. Awesome. So any questions?